Welcome, everyone. This is Puneet Kulkarni with Harman. We're just going to give a few minutes for everybody to join. Thank you. Hello, everyone, and welcome to the third industrial revolution. I'm Puneet Kulkarni, AVP Marketing at Harman International. Most of you might know Harman from its sound engineering excellence with brands like Harman Kardon, AKG, JBL, Infinity, to name a few. But a few months ago, Harman acquired Symphony Teleca and Red Band Software to expand its capabilities into data, analytics, software, and expand its footprint into the Internet of Things, or the IoT space. They say that as many as 50 billion machines will be connected to the Internet by 2020. Cloud, predictive analytics, APIs are latching these individual machines together to become a large-scale intelligent ecosystem that can perform functions that were not possible before. An estimated 100 trillion sensors will be out there by 2030, contributing to the big data that will identify unseen patterns and in turn will make these machines even more intelligent. The panel for today's discussion is made up of industry thought leaders who will discuss their perspective and vision for this third industrial revolution. We have Frank Gillett, Principal Analyst at Forrester. Frank is also the moderator of today's panel discussion. We have Darrell Swope, Head of Global Architecture at Landis+Gyr, and Landis+Gyr is a large provider of technology to manage energy and utilities. We also have Grant Bodley, General Manager of Global Manufacturing Solutions at Ortonworks, and Sriram Jayaraman, who is the Vice President of Consulting at Harman. With this, ladies and gentlemen, I would like to hand over the stage to Frank Gillett to discuss the trends in IoT and his vision for the third industrial revolution. Frank?
Thanks very much, and welcome everyone. We appreciate you taking the time to check in with us today. What I want to do is give you an overview of the Internet of Things as Forrester sees it, with some market background, and set the stage for the discussion that we're going to have with the panel. So what I want to do is show you how IoT usage already is broad and, we believe, growing. But let's start with sort of an overview of the really broad perspective on the range of IoT solutions that are out there. We're going to zoom in on the top half of this funnel and start with a look at planetary scale things. Of course, you can put sensors out in the environment or in the field anywhere on the planet: ocean buoys, oil drilling rigs, and environmental sensors. But we see things happening at city scale too. So there you see traffic lights, the street lights, and plans by cities such as Barcelona and Dubai to create smart cities. But then you can drop down into the power grid, the roads, the energy generation in wind turbines, and see it at that kind of infrastructure scale systems. But then if you drop into the bottom half of the funnel, you're really looking at the level of campuses and buildings, factories, stores, hospitals. These are static assets, but you also see industrial and commercial assets, whether it's mobile ones, such as you see here, trucks and aircraft, ships, but it can also be large static equipment in a company. So it can be within the building, manufacturing systems, and a wide variety of things, and we'll give some more examples of that. But once you get past that, then you're really looking at the level of assets that belong to families, so homes and automobiles. And then you get even more personal, right? Contents within the home, the appliances, consumer products. I personally use one of these Wi-Fi bathroom scales. I've found it very helpful to get daily feedback on where I'm at, and it's actually shaped how much I eat, and in a good way. And then you get to the bottom here, and it's personal assets. It's the things that we carry in our pockets, clip to our waistband, that help give us feedback or extend the utility of smartphones with more information about the physical world. So there's a very broad spectrum of the Internet of Things. What we're going to do now is touch briefly on some adoption data, and then talk about why the Internet of Things is valuable to businesses, because often there's too much focus on how many trillions of devices will be connected to the Internet, or how many billions of dollars will be worth. Actually, I think I get that wrong. It's billions of devices, trillions of dollars. But let's first talk about the actual sort of adoption out there. Now, Forrester surveys many audiences, and surveying for IoT can be particularly tricky because it can be found in many different parts of a company. So one of the proxies is you ask the network people, and they're not going to know about all the IoT things. For example, if it's cellular connected, they may not know about it unless it's something that the company puts out. But often they know a lot about what's attached to their network. So these are the results for enterprises, that is companies with 1,000 employees or more, across 10 countries early in 2015. And what we found is that 24% of the companies that we surveyed reported they've already implemented or are expanding their use of the Internet of Things. And another 29% report that they plan to implement some IoT deployment solution in the next 12 months. Now, we know from long experience with surveys that that does not translate into 29% of companies will move in 1 year. We know it's a fraction of that number. So we take that as an indicative, an indicator of how strong the interest is in the Internet of Things. Now, keep in mind that IoT has existed for decades, really. If you look at programmable logic controllers from, say, the 1970s, what's changing, though, is from those earlier analog systems and those disconnected systems, they're now getting connected to the Internet, in addition to all the new technologies that we're hearing about under the title now of Internet of Things. So in some ways, we think these numbers probably underrepresent what companies are actually doing. However, it's in so many different pockets of the company that it's a reasonable approximation. Now, I'll just call your attention to the number on the right, that 30%, beyond the 52% that said we're using or planning, an additional 30% reported that their companies are interested in the Internet of Things use cases, but do not have plans to implement within 12 months. So if you sort of add those together, you get 82% of companies using, planning, or interested in Internet of Things. Now, if we look at this by industry, and again, this is actually this is now North American, so we switched from a global perspective a moment ago, so now we're looking at North American industries. The details are at the base, and this includes both large and small business. You see heaviest in real asset-intensive companies like utilities and telecom. And note the subtitle here. This is the sum of using and planning to use in the next 12 months. So utilities, chemicals, transportation, and high-tech production, all above 50%, primary production at 50%. And then if you drop into the others, you see it fall off some when you get down to healthcare, government, education, and so forth. But pretty good adoption across the board, but definitely varies by industry. And there's sort of a loose correlation with two things: the asset intensity of the industry compared to their revenues, and the on computer technologies, because that's a good proxy for their interest in using technologies like this. Now, we'll give you one other look at adoption data by region of the world. So what are your firm's plans to adopt IoT solutions or applications? And these are aggregation of multiple countries within these regions. So you'll see China and India folded together. That number, we believe, is disproportionately high because we survey only in urban areas in those countries, and so we think that there's a disproportionate number of respondents, and that the true adoption is probably more in line with what you would see in Latin America. But the other numbers, we don't feel like there's a fudge factor we need to add, but we like to report the actual results we got and then give you the commentary. So you see strong interest across the regions, but especially in the emerging markets. Now, let's talk about what makes IoT so interesting. Well, fundamentally, it enables a form of automation, which we're going to talk about more when we get to the panel. But IoT data drives a feedback loop that helps you digitize business, and we believe, most importantly, really helps, in many cases, companies think about how to drive and improve customer experience and engagement. And if you sort of take these representative sensors at the bottom of the screen, the data about the physical world drives an awareness of what's going on in the physical world that simply wasn't there, wasn't possible before you got this data about the physical world in real time. That enables analysis. It enables an automated development of the alternatives, i.e. what you should do about the insights that come out of the analysis. And then that enables automated action. That is being able to either automatically adjust the machine, turn on a light, or send instructions to a human to take action out in the physical world. So that return path that goes down to the sensors around the right side can be either humans or machines. But at bottom, the Internet of Things always has a sensor out in the real world, and I believe it's independent of your smartphone. I don't think it's useful to talk about sensors running around in smartphones. We know what that is. That's mobile. So think of this as sensors beyond mobile that give us information about the physical world and drive this whole feedback loop, the 4 A's that enable awareness, analysis, alternatives, and action, that real step and possibility of automation. Now, this leads to 3 levels of IoT value proposition, and we believe these are sort of in escalating forms of business outcomes. The first one is the optimization, the focus on efficiency around physical assets. The second one is being able to use this information about the physical world and what's going on to drive innovation, to create new products, new services. It's very clear if you're putting sensors in a product that you're able to innovate and differentiate your products by doing that. But it's also true of manufacturing processes or internal processes of a company, because you can speed the result, create more flexibility, create a lot more interaction and collaboration. But these two aren't sufficient to really characterize the potential business value, because we believe that the third level is the most interesting one, and that is to be able to transform your company. And this is fundamentally about changing the way you engage with customers. The idea that your product could become a service, that could have a complementary service, or could in fact become product as a service. But it really enables you to fundamentally rethink things. So in the consumer space, think Zipcar instead of buying a car, where you're using a car by the hour and putting it back where you got it when you're done with it. Or think Kaiser Compressor in Germany, that instead of selling air compressors, sells liters of compressed air. So they place a compressor at your site, and you pay for the amount of compressed air that you use. Now, I really like this quote from Russ Fidel, president of ThingWorks. We're going from using the customer as a sensor to find out about the product's performance, to putting sensors in the product to learn about the customer's experience. That really characterizes what IoT is like for product companies. But let's look at that, because it turns out there's 2 types of connected world use cases, or IoT. And the first one is for companies that make physical products. Now, not all companies do this, but for any company that makes a product, either a consumable product, paper, fuel, coffee, cereal, or a discrete product, automobiles, computers, staplers, this applies. And it's not that you can put sensors in coffee or fuel or soft drinks, but you can put sensors in the dispenser of those products. So OEMs across many markets are in this position where their product people can now enable their products with sensors. But all companies can take advantage of this second use case, and that is as an operator for business processes to use connected assets to drive how they run their business and to change how they run their business. So now let's look at this from the point of view of the constituents, the two audiences that can take advantage of IoT. Well, in the maker use case that I just outlined, it's the product design, marketing, and customer service staff who get all the data from connected products and are able to use that to automate actions back with their customers. And these are customer-oriented people who don't necessarily have a lot of techie knowledge with which to figure out how to deploy IoT in their products. Now, the IoT operator is a very different set of constituents. That's business process and operations staff who are used to working with assets and running business processes, but they don't necessarily have a lot of experience with taking advantage of either technology or the intense amount of data that these can generate. So whether you're thinking about it in the product design use case or the business process use case, that is maker or operator, these audiences need a lot of perspective and help to figure out how to take advantage of IoT. Now I want to show you a list briefly of a number of examples about connected assets and then touch on their applicability or use in manufacturing in particular. So let's see if we can get, there we go. So here are some examples that Forrester has surveyed about to find out the degree to which people are using IoT for these kinds of use cases. So you can see on the right near the top, smart products is only one of those. Most of these are about running better processes within your business, though smart home management is an outcome of a particular class of smart home products. So all of these involve companies using sensors on their assets to run better internal experiences, including energy management, which would be part of building management. But what I want to focus on today with our particular emphasis on manufacturing is the notion that IoT is really enabling the next industrial revolution. And the photo on the right is of Germany's Andrea Merkel. And the Germans in particular, but Europe in general, has been really big on this idea that IoT is going to enable the next industrial revolution, that is, the next generation of rethinking of manufacturing. And they use the term Industry 4.0, with the Germanic interpretation of IE on the end instead of Y. But Industry 4.0 is the term they use to really describe this notion of embedding sensors throughout the manufacturing line to really revolutionize how you manufacture efficiently. And they use this term cyber physical systems to describe that. Now, we actually think that sometimes this notion of a new industrial revolution in manufacturing, that the Industry 4.0 guys aim too narrow, that they really need to think broader, not just in terms of the smart factory, if you will. And here's some of the benefits from the smart factory, but we also believe that it's about kind of rethinking the whole thing end to end and the entire societal context and really changing how you do manufacturing beyond just the production line. So improving product componentization, that is more customization of products and tailoring, so allowing smaller lot numbers. Energy efficiency, being able to use machinery, not only increase its utilization, but actually improve the efficiency of the machinery. Urban production, basically thinking about how to site all the pieces closer together, thinking about the whole extended value chain and supply chain as an integrated system rather than as a disconnected set of parts. Creating a resilient architecture and a dynamic production system that really creates integrated client-supplier collaboration, and we don't just mean from the OEM to the Tier 1 suppliers, we also mean out to the customer. and there's a company in Germany called Phoenix Contact that uses the fine-grained control of its production line to work with customers to enable them to do really customized products and to embed all the documentation around these relays and circuit breakers, such as material safety data sheets, right into the product in ways that just are not possible with conventional manufacturing. So what I want to do now is wrap up with a couple of slides about how this looks technologically, and then move to our panel discussion. So when you think about putting something into place for Internet of Things, you're really talking at the edge about things in the networks. And these are the sensors and the device packages that attach to the sensors that enable them to have a network attachment. And then the gateways, these electronic bridges that let them get out to the network. But those in turn have to be backed by software that pulls in the data, translates the unusual and specific protocols that these products use, manages the devices, converts the data. And this is where you then get out into familiar enterprise infrastructure, because here you're getting into application programming interfaces or APIs, aggregating the data, setting yourself up for analytics. And this is where it starts to plug into the mobile infrastructure that we're used to, this is the first step that's familiar, because these things on the left, things and networks, in the center, ingestion and delivery, those are much more specific to IoT. And it's finally when we get up to this level that you're looking at enterprise. And then when we think about the action loop that we talked about before, awareness analysis, feeding it upstream, turning it around in this layer, aggregation integration alternatives, and then driving action back out to the edge. And you can see on the right side, all of this means looping through and including what Forrester calls the services tier, that is the conventional enterprise applications. So pretty complex software architecture that is built to make this work. And I wanted to call out, particularly on the right-hand side here under aggregation and integration, the role of API management, of analytics, and then automation to make all of this work together with existing enterprise applications, but incorporating Internet of Things. So if we think about the overall situation here, the Internet of Things creates an enormously diverse and set of opportunities, but they're quite specific to each business and use case. These use cases often have potential for customer and competitive impact beyond cost savings. So we believe it's important to step back and not just get enthralled with the potential for efficiency and cost savings, but to think about that potential for product differentiation and transformation, and design your approach for IoT to keep those avenues open. Now, we believe that the Internet of Things will also drive lots of new security and software challenges for the next half decade. This is not going to be a quick burning revolution. It's not like the smartphone. It's not as simple as that. We believe it will be quite an iterative evolution that will have fundamental impact in many industries, especially in product industries, but quite often in service and process industries as well. So I want to wrap up here. You see my Twitter handle if you care to check that out. And I want to move now to our panel discussion. And we have 4 topics queued up for you today. And we're going to, let's see, what I would love to do is be able to
Frank,
show you, yes?
Frank, I'm sorry, this is Puneet.
Jump in.
I had a quick update for the audience.
Yeah.
On the right-hand side of the panel, there is a way for them to submit the questions. So we will have, at the end of the session, we will have the top 10, 12 minutes to answer their questions. So audience, feel free to submit the questions that we can even actually possibly bring them into the current conversation. Thank you.
Yeah, great. So thank you for that reminder. So yes, it would be great if, as we're doing the panel discussion among our 4 guest speakers here, if you could put your questions in. We'll try to incorporate some of them in the ongoing conversation, and then the rest, we'll also reserve the more complex questions for a specific Q&A discussion at the end. And I do see we've got one question already queued up about getting a copy of the presentation, and Kunal, I'm hoping you will answer that one. because I don't know the answer to that one. Let's go into our first topic here, which is intelligent automation. Darrell, I'd like to turn to you and see if you can introduce yourself to the audience here and share what your experience is in the energy markets with automation.
Okay, be happy to. So I'm Darrell Swope. I'm head of global architecture at Landis & Gyr, and we do. I would say we're sort of at the forefront of this Internet of Things. It's something that we feel we're already doing.
Mm-hmm.
Some really good examples, I think, where we see utilities that have really latched on to this technology has been, and by the way, I liked your framework around optimize, innovate, and transform.
Uh-huh.
And I think I see that same kind of pattern in the utility space. But in terms of them optimizing, for example, they're using not only things like data from meters that they have out in the field, as well as connections to their distribution network to understand where they might have problems, where they can proactively do maintenance to really reduce their costs and optimize the performance of that distribution. But beyond that, they're also looking at how they can actually change the business model for utilities, and they're very much in tune with how things like distributed generation and basically the ability to localize a lot of their functions is something of a threat. And they look to these types of technologies to help them stay relevant, transform things like load management, which would be how they control the distribution of power and at what levels, to be something that consumers can participate in terms of lowering their costs and in terms of controlling when they get power, which would help the utilities in turn produce power for them cheaper. So falls very well, I think, in line with some of the points that you made earlier.
Yeah, and well, certainly in the electrical utility landscape, that kind of automation to deal with the dynamic nature of generation and distribution makes a lot of sense. But Grant, I want to turn to you. You know, discrete manufacturing is very different from power generation. You are at a company that sells some of the solutions into manufacturing companies. What do you see around sort of IoT and intelligent automation, and as you help companies think about how to analyze and manage the data that is streaming off their sensors?
So Frank, here, this is Grant Bodley from Ortonworks. I have a career-long focus on manufacturing for the last 25 years, worked for several manufacturing industries and for Ortonworks. And I'm really excited about the way that we are addressing business problems in ways that were not previously possible. If you look at manufacturing, for example, the availability of low-cost sensors and communication technologies is enabling manufacturers to connect their products and their operations and to get new insights on improving the operation from end to end. And you mentioned this in your early discussion as to, I think most manufacturers have exhausted their local optimizations at each point in the process. And the holy grail really is to get a single view of data across the manufacturing process. The problem is today that if you look at the number of manufacturing execution systems, SCADA, historians, quality systems, etc., and each machine in the manufacturing process having its own proprietary software and data format, it's very difficult to get a single view of that process. And that's really the problem that our company is looking to address, is to provide a complementary single view of data to be able to close that feedback loop that you described in the data, rather than having to go through the costly and time-consuming process of re-engineering the underlying applications to be better connected. But you can actually do that in the data. And that's really the secret that can open up a lot of new possibility and speed.
Great. So what it sounds like your experience is looking at is how to give people sort of not just a single view of the data, but of their entire process, right? I mean, well, in your case, it may not be a live interactive view of the process, but nonetheless, the point is to create a view across the entire business process, which is, as you suggested, was not possible in the old world of I'll call them isolated sensor systems that existed, as you mentioned, say, in SCADA and some of the historian capabilities before, although these technologies are now trying to advance. I want to check in with Sriram to hear about your experience looking at the different clients that you work with in seeing sort of IoT used for intelligent automation, but I'll just note what Grant told us about, which was this challenge of integrating disparate systems, because we're going to come back to that when we talk about machine connectivity and APIs. But Sriram, let's hear from you about your experience with customers and intelligent automation.
Well, the experience about customers with intelligent automation, what we are seeing is like, I would take the classic example of GE, where one of the guys who are building the Predix platform, he said that, well, when I went to sleep, I thought I'm an industrial company. Today I realize I'm a software and analytics company, to the point which Grant made earlier. The biggest challenge for these people is that Internet of Things is not about just enabling the connectivity, as you mentioned in your slide. It's also about meaningful sense out of that particular connectivity. Like, for example, what people are doing in GE Healthcare today is predicting which NFL player in a particular team has the highest risk of having head concussion. We have people, and also in Boeing, the Internet of Things is helping in knowing that what will be the longevity of the wings on their flights on the new 787 models. And these are huge impacts, because the flight skew is 156 million for Boeing, and the ability to predict this is something which is going to save them close to 5 or 6 million. So the impact for them is huge, but the challenge for them is also, like what Darrell pointed out, thinking the holistic big picture. It's not necessarily a piecemeal effort where you say that you can't think like towers when you're thinking about realizing the value on IoT. You have to think about the holistic business process in order to achieve your goal. So that's what we have learned as the key takeaway from our customers.
Great. So I want to keep an eye on the time here and move to our second topic around IoT enablement, connectivity, and APIs. So Grant, I'm going to come back to you, because you mentioned the challenge of sort of disparate systems, and then Darrell, I'll check in with you, and Sriram, I'm going to keep putting you last because you've got this great broad perspective. But Grant, you had talked about the difficulty of sort of the isolated traditional IoT style systems, but now we've got new ones coming in. Can you say more about the sort of variety of landscape and why we need to be thinking about the details of connecting these machines? I mean, aren't they all like on IP networks, and isn't this easy?
Yeah, interesting. You should say that. So I think one of the biggest challenges we face is that in manufacturing, and this is the world that I'm living in right now, and it's true for lots of other industries, but in manufacturing we typically are dealing with what we call a jagged edge. And by jagged edge, we mean the edge of the network, and this could be the source of data from a sensor to a high-definition camera to a Twitter feed, Internet of anything.
Right.
We're typically dealing with a complex network of heterogeneous sensor types, lots of different data formats, and security is key. So it's really important to make sure that machines cannot be hacked, that data is propagated from the edge to the data persistence layer, could be the data center, and that this data comes at the right priority as well, because you may have a sensor that could be sending the same reading over and over, but you may not be interested in that until it changes. But once it changes, you may want to increase the sampling rate and get more context on the change so that you can better predict what to happen and take the appropriate corrective action within a short window. We call those perishable insights. So it's really, I think we're dealing with a heterogeneous environment, and you really need a data flow solution that can take care of the complexity and also the security and the speed.
Right. Now, you mentioned sort of the variety of sensors, the variety of connectivity. You know, there's a lot of proprietary radios. But what about software protocols? Aren't there standards for that? Isn't that sorted out so that the communication is easy, or no?
No. So there are so many different proprietary software environments, each with a different data format, and it's really important to have a solution that can bridge all of that complexity. So typically, you know, if you looked at a data flow solution to bring data from the edge, typically companies try and stitch together 6 or 7 different solutions, which makes it even more complex. But there are solutions available. We have a solution called Data Flow, which allows you to to cover most of those requirements with a Swiss Army knife of data flow
Mm-hmm.
to be able to do that with. But I think the reality is, and it's going to be for a while, that there will be a lack of standards and there will be this very heterogeneous environment, and that's a reality that we need to address.
So, Darrell, I want to turn to you because unlike Grant, who's having to look across a wide variety of company types in manufacturing, I mean, it's sort of one vertical, but it's very broad. Electrical power generation and distribution feels more constrained to me. So, could I speculate that the standards and technologies in power generation and distribution are, and frankly at the edge on the smart meter, that's all sorted out, right? All the standards are the same, hopefully within at least one country, if not across the globe?
Yeah, it's all done. We're really pretty much finished over here, so we're moving on.
Well, yeah. So how chaotic is it within even that narrow world? It seems like it would be less crazy, and of course you've got more uptight security requirements than most, I would think, since you're literally keeping the lights on.
Yeah, no, that is one of the big challenges. But I think what we're looking at in the utility industry, and I think Grant probably sees very similar kind of things as well. One other challenge I think for utilities is their equipment obviously is widely geographically dispersed. They've had to employ a number of networking technologies that are extremely low bandwidth in some cases in order to cover great distances with low power utilization, things like that.
Well, is that because they used older technology, or even today are they choosing very low bandwidth technology?
Well, I would say that there didn't used to be, I think, at a cost point that was
so it's gotten better,
reasonable,
right,
to put out onto several million meters or several million transformers or something like that, that you could have the type of power and bandwidth that it made sense. So you had, companies using things like power line carrier, where you're carrying data over the power lines themselves, which is very low bandwidth.
Yeah.
And today, though, I think we're seeing the same kind of consolidation around technologies that we probably saw in the LAN and in the WAN areas, 20, 30 years ago. So things like you mentioned before, we had lots of proprietary technologies, and a lot of those because they had to optimize. They had to be very, very highly optimized or to operate in these highly constrained environments. But now what we're seeing is a big transformation and a big demand from utilities and from regulators that they need to be standards-based. And so you see a lot of these standards, some of them that you're talking about, that are coming to the forefront. Now, in a lot of cases, standards-based networking is not as efficient as some of the proprietary offerings that people have had in the past because they had to operate from highly constrained environments. But we're operating in an environment where that's not as big a deal anymore. Just like when we had higher power computers and higher powered wireless protocols, the increase in bandwidth is making that less and less of an issue. And so you see more and more of a push toward standards, interoperability, and interoperability at a number of levels, not just at the networking level, but also at the application level. So in terms of data exchange formats, like you mentioned, a lot of those things do exist, but as soon as you start hooking things together from different vendors, you realize, it doesn't work completely 100%, and those are kind of the areas that I think are being worked out now.
Right. Well, let's turn to Sriram. And Sriram, I'd like to hear your perspective on what you see across other industries, because we've gotten a view into two, utilities and manufacturing. But I want you to comment in particular about the role here of APIs in connecting to all these different machines, dealing with the different protocols, and just making all this stuff work together.
Yeah, so I classify it as two different problems. I would classify it as the second mile problem, which means from protocol gateway perspective, and then the last mile problem. So why do I call it the second mile problem is that after you connect, the first problem which people land up with is the fact that, as rightly pointed out by both of them before, the proprietary protocols are far more efficient. At this point of time, you also have some agreement like the all seen as with all join and everything, where everybody wants to go the same route. The reality is you have to deal with variety. Okay, variety in terms of protocol, variety in terms of the data which is being generated. So that's the problem which gets solved between both a platform like Hortonworks, which can handle the variety of data which is based upon table, serial, or whatever, and some protocol gateways, you can handle different kind of protocols which are coming in. But what is more important is, like when you showed your architecture diagram, planning your action layer, okay? So, and actions are going to be different. Every mission algorithm which we are processing on top of the data, we are going to have diverse set of actions. And we believe this is where microservices offer a massive level of value. Now, why is it? Is because the paradigm in IoT solution is that every action is self-contained. Every action does not necessarily share their processing power or compute power. At some point of time, let's say, for example, like a movie playing equipment or a movie delivery equipment, the streaming of movies is completely different action from the charging of the movie. Okay.
Yep.
So, and you wouldn't want to distribute both of them disturb both of them using the same shared service in your set-top box. So you have to start thinking microservices in order to achieve that. So the long story short, the diversity is a reality, and the variety is at least a reality from a protocol or the second mile problem perspective for the next 2 to 3 years, because there are going to be old devices which people are not going to switch over. And last but not the least is that you need to think about your services being self-contained, or else you can't make this successful.
So I think what you said, the microservices comment, is particularly interesting and not obvious, because just because you can throw up APIs doesn't mean that the software stack behind it turns into this, flexible, easy to use, set of software that you can evolve with the business. So I thought your comment there was particularly telling. I want to call out some questions we've gotten from one audience member, and I would encourage others to submit questions. I'm going to keep working the panel here and feeding your questions now into the dialogue. So our questioner here wants to know about the biggest challenge introducing the importance of gathering data from non-mobile sensors. And so I'm going to translate that. I'm going to make an assumption here that non-mobile sensors means things that are not cellular connected. So what's the biggest challenge of pulling data from sensors that are connected over Wi-Fi, Bluetooth, Ethernet, don't have to deal with the cellular connection? Do any of you want to take that question and give a quick thought?
Yeah, I'll take that first. We worked with a retailer whose communication protocol was only NFC and Bluetooth. The challenge in that particular, so they were primarily using iBeacons and NFC and Bluetooth, not even FFCs, only NFCs in order for the communication with the apps. And it's non-mobile. So given that particular case scenario, one is that when it's not Wi-Fi or mobile connected, reliable messaging is not a reality. So you can get some pieces of pockets, and some pieces of information might come in later. So what you need to think about is that of implementing a reliable architecture pattern, like something like command query responsibility segregation or event sourcing, using which even if the connectivity drops or the connectivity is not predictable, you are still in a position to assemble the data with a limited amount of latency as compared to that on a continuous basis. The second one, which is there, which is a big challenge, is that of thinking and identifying smart field gateways, because solving that intermittent connectivity problem is not only a cloud side or a IT side problem, as you pointed out during your presentation. It is also a thing of, what do you call it, identifying the most cost efficient, but also the most smartest field gateways which are available in your location. So,
and can you clarify what you mean by field gateway?
All right, so to keep it simple, so we have a protocol gateway which is inbound, receiving information and then translating it. But
so is a gateway a hardware device, or is it a software, or is it a combination of the two?
It's a combination of the two. In field gateways, it's a combination of two. In protocol gateways, it can be purely software. Yeah.
Got it. Okay, great. So let's see if we can shift to our third topic around creating business value, analytics, and real-time insights. But we're going to come back to questions as we go. We have a couple more queued up here, and I would encourage you all to submit more questions. If you prefer to submit something informal, you can do that in the chat window. If you've got a good structured question, drop it into the question window for us. And I'm going to start with you, Darrell, looking at this question of business value, analytics and real-time insights. Help us understand what you've seen in the evolution of the electrical utility industry for the use of analytics and in particular real-time insight, which I would think be very important in the distribution network.
Yeah, it really is. And you know, one of the customers that we worked with has used what I thought was a very innovative approach, where they, you know, one of the big statistics, one of the big measures of success for utilities, particularly with regulators and customers, is reliability and how they respond to events like storms, so outages. Mm-hmm. And this is a key point of customer satisfaction for them. So this particular utility was really looking at how can we, as a vision, as a goal, make it such that when a customer picks up a phone and calls us and tells us, hey, power's out in my house, we're able to tell them we know, and we've already sent a crew out, we're already on top of it. Mm. So what they've had to do on that is take a couple of data sources, and one of them, you know, in terms of distribution network assets is in place, but also they're able to use actually the metering data, you know, from the house meters to help them do a couple things. One is to really segment where they believe that outage has taken place, so they know where to converge on it even before they're necessarily getting, you know, phone calls and that's feeding through their customer support. But it also gives them some idea of breadth as well in terms of, you know, how widespread is it, how many people do we need to mobilize. So they've done a lot of work in automating their outage response so that they get these messages from the network, they go and create automatic work orders for crews that can then be dispatched without necessarily having to rely on customers to provide all that information for them.
Right. Now, Grant, I'm going to look at you with your sort of focus on kind of data infrastructure. What does it take to be able to create real-time insights? Because it's one thing to be able to, say, put up some dashboards and have maybe some event triggers like Darrell described in the electrical industry, but I got to think it can get more complicated than that, and the sense I have is that there's quite a difference between real-time insights and historical stuff. What can you tell us?
So typically, there's a journey that our customers go through, and they start. It's really a three-phase journey, starting with data discovery, and then once they get get enough data in the hands of the business can start to look for patterns and can start exploring hypotheses on what could be the cause of things like yield loss and quality issues. And we have an example where one of our vaccine manufacturers had, you know, they were experiencing significant yield loss in you know, one batch of a vaccine versus another with the identical manufacturing process, and they have 200 variables.
Wait, so there's two different production lines, and they were trying to figure out why one was behaving differently?
No, one production line, two different batches.
Ah, got it. Okay, thank you.
So you know, where you have, so in this situation, what was required was to be able to do batch-to-batch comparisons, and in the past, it took very laborious, time-consuming process to get two batches and compare two batches, which is not statistically accurate. With the data platform that we provide, they were able to bring together all of the data of every batch of a vaccine ever produced over 10 years, and they did 5.5 million batch-to-batch comparisons, and they were able to then dial into, of the 200 variables through manufacturing, these are the 3 or 4 that are the biggest offenders that impact in yield, and then could control those better. So that journey really was, you know, it started with data discovery, bringing together all of the data of every batch of a vaccine ever produced, looking for hypotheses and patterns in the data, to the point where they could get a single view of the manufacturing process, and they would get to a point where they would know exactly what to listen for in real time to then proactively manage variability and minimize it within a short window. So there were things that happen upstream in a manufacturing process that could have downstream implication, and there's a short window before a batch gets contaminated, which could cost $1 million, and downtime. So if they're able to nip that in the bud and address that within that window, they are able to, you know, add millions, tens of millions to the bottom line.
Right. Wow. So there's a real big loss avoidance that they're able to do, as well as really avoiding delays in delivery of product according to schedule, so reducing variability of the results. That's pretty powerful.
And in this example, they were able to provide 40,000 more doses of a vaccine, which would be, life-saving, but also have massive revenue implications in the tens of millions of dollars.
Right. Now, to what extent does that? I mean, one of the things that we hear sometimes is this question of, to what extent can we use existing data versus having to go out and add new stuff? But I assume from the point of view of your experience, it doesn't matter whether the data is already existing or is just being generated by new sensors. It's equal in the eyes of the analytics, right?
That's right. So what we are most often doing is freeing trapped data in these siloed, disconnected applications and bringing that into a single view, into a single data set, and then bringing in some of the external sources of data. It could be temperature, pressure, pH, environmental, building sensors. You could be bringing machine service history. You could be bringing structured data that describes the anatomy of machines in the production process. For example, it's lot genealogy and all that sort of thing, bringing it all together, all of the quality test data. So these are new sources of unstructured data together, correlating those with structured data and being able to get new insights from that combination. So the secret is you need to see the full picture as a business person to make the right decisions. And if you don't have that complete picture, that single view of that process or that product or that customer life cycle, then you should know what's happening, and your decision-making will be more of guessing than actually making sound decisions. So we really look to put the data in the hands of the business, allow them to look for patterns, and ultimately get to a point where they can switch from descriptive analytics about things that happened in the past to going to predictive and prescriptive analytics and really being able to predict what's going to happen and take action before that window closes.
Got it. Let's turn to Sriram for a brief response, and then we've got one more topic to cover before we get to the top of the hour. And again, I want to encourage the audience to submit any questions you've got for our panelists. And we're about to go to project ideation and proof of concept. But Sriram, tell us briefly about your experience of analytics and real-time insights for IoT.
Well, every IoT workload which we have worked with, I classify the analytics as two different categories. One is what I call as hot analytics, and the other is what I call as cold analytics. Okay. You use platforms like PurePlay, Hadoop, and everything to do your cold analytics, which is later, but that doesn't mean it is descriptive. But most of the cases, it's either predictive or prescriptive, as Grant pointed out. But we have seen case scenarios, like, for example, healthcare is a classic example where your predictive analytics has to be done virtually in real time. So, for example, if a guy's pulse rate goes beyond a particular point when he is doing his workout, if you need to slow him down on his workout, then we need to be in a position to respond literally in real time. And that's also a predictive or a prescriptive scenario, but for which there are technology alternatives available from pretty much the entire world, like Microsoft as its answer using Azure ML and Event Hubs, Amazon as its answer using Kinesis, Ortonworks or the Hadoop ecosystem as its answer by using a combination of Kafka and Storm, in which you can have. So the bet is that if you're going cloud native, you don't want to be tied to any one of these providers, you are going to be in a position where you are having both hot and cold scenario. But just like the way Grant pointed out, you can't just use hot analytics for the heck of it. It is dependent upon the business scenario and the business value which it brings in. If it is saving somebody's life, then yes, you do it, or else don't do it. Yeah.
Right. Do you have real-time situations where there's a lot at stake, whether it's money or life? Let's move to our last topic here around project ideation and proof of concept, and I'll encourage people to submit any last questions for us to consider, and I'm going to pull from an existing question here. What are the common technical difficulties in implementing IoT? And let's come back to Darrell first here. In the work that you've done in the utility industry, what are the complexities of the IoT project, and what are the common technical difficulties?
Okay. Well, as I mentioned before, utilities, we tend to deal with lots of scale, and that's a huge challenge. Is we're dealing with sometimes millions, tens of millions of devices, and data collection rates that can be very high. So scale from the front all the way to the back is an important consideration. Security is as well, and that's because we have assets that are unprotected in the field. In our case,
physically unprotected. I presume that
physically unprotected, right?
Electronically protected.
That's what I mean.
Yeah.
Physically, unprotected, such that they're susceptible to vandalism or physical intrusion attempts, those kinds of things. So that is a big challenge, particularly when you're dealing with, and I think you mentioned earlier, critical infrastructure like an electric grid.
Right.
But the last thing I would throw in is related to just the breadth and scale of the physical deployment, because when you're going to go and put devices out over a geographical area, a large geographical area, particularly when we're talking about wireless technologies, there's lots of complexity around how you design those networks and how you manage power levels and interference and all those kinds of things. So there's a number of complexities around just how do you get these things out there and all the different configurations you need.
Now, one of the things that I see in this space is this question, you talked about scale. There's scale as in giant gobs of a lot of data from perhaps a few assets, so jet engines and aircraft spit out terabytes of data, but you don't have millions of them, right? You have hundreds or maybe a few thousand of them. But then on the other end of the spectrum, you can have millions of products in the field spitting out data. Often that's a consumer scenario, and in your case, electrical meters are consumer scenarios. But I just wanted to call out for our audience that question, and we're going to go to Grant here in a moment with an audience question. But our audience today should be thinking about scale in terms of number of devices as well as quantity of data per device, in addition to this question of, are you trying to track real-time events, or are you trying to look at historical? So Grant, let's turn to you, and we've got an audience question here, which I'd like you to work in as you give your thoughts on ideation and proof of concepts. The audience question is, how do companies develop business cases and get approval for funding? And implicit in that question is, who does it? And so I don't know the role of our questioner, but I mentioned before we've got product people, we've got operations people, and then of course you always have IT people in a company. So Grant, when you look in your experience, can you answer this question about how you see companies developing business cases? Who develops it?
Absolutely. So it just so happens I've just completed a 2-day exercise with a company in Germany, and exactly on this topic. And I think the important thing is to first start with the business use cases that are really going to drive meaningful business results.
Okay.
And make sure that you have a clear understanding of where the business demand is. And in this case, we looked at existing initiatives that were already underway versus new initiatives that could have profound impact. And then work through. So we actually we have a customer innovation and value part of our team that actually focuses on doing design thinking workshops with customers to be able to quickly identify where the low-hanging fruit could lie, which use cases could be more strategic and maybe more ambitious versus those that could be done quicker and can provide some low-hanging fruit. And I think generally you don't want to boil the ocean. You want to look at getting some success around. Typically these data platforms and data flow solutions are newer technologies, and you need to make sure that you partnered with the right partners who understand these technologies and can help you architect that to complement your current environment. But I would encourage you to start out with the business requirement. We could help to facilitate those workshops to rapidly get to, what is the business requirement, what's it going to take architecturally to deploy that in your current environment, and how can you crawl, walk, run in a phased approach where you may start out, maybe you don't have to look at the entire manufacturing process. For example, you could look at quality, or in the automotive industry, you could look at connected car data, or you could look at factory automation. There are many different starting points that you could pick, and then, get success there, and then take that, and then after that, it tends to go viral.
Right. Darrell, let's get you in for a quick comment. We're almost out of time, well, no, actually we got you, Darrell. Sriram, let's go with you. Sorry. Quick comment on what you see for sort of POC and how this gets started. And my general sense is this is bottoms up in most companies, and so you find a business owner with a problem, and you kind of do it that way. What do you think?
Well, I think in the similar lines, but the way I think about it is think big, start small. I'll put it that way. Think about the holistic problem from a business process perspective, but your process scenarios, you might have 15 or 16. IoT is a classic candidate for what I call as agile execution. Start building capabilities in 2 weeks or 3 weeks in piecemeal. And from a funding perspective, our model has always been a show and tell model. So, like for example, we are working with this construction company worldwide, and we showed the value of saving energy 20% for one particular building on a commercial real estate basis. And obviously, they knew the value and they are replicating across the world. Okay, but the holistic thinking in terms of the values there, but start small and executing a complete swim lane, and don't try to just solve the problem saying that make the device is connected or it knows how to get connected, you solve the problem. It doesn't work that way. You should see the end-to-end value. After that, even with one single scenario which is more powerful, after that the rest of the adoption automatically follows up with these people.
Great. Puneet, I'm going to come back to you. We're at the top of the hour. And I probably caught you up
Absolutely.
short.
Well,
go ahead.
So no, I think this has been a fantastic discussion. Thank you so much to the panelists and to you, Frank. I think you know, this was a very interactive. I know there were a couple of questions on the PDF of this session, so we won't be publishing the PDF per se, but all the attendees will be receiving a link to the recording of the webinar, and it will also have a URL to sign up for an IoT Fusion workshop that we can run for them as organizations. So, you know, I think thank you so much for the audience as well. You know, it has been a fantastic interactive session. Thank you so much.
Thank you very much. Have a good day, all.